All right, so let's answer this question with polar. What's the area of a circle? Pi r squared. Okay, good. Draw the region you're trying to integrate over, and then what am I going to try to integrate?
Small region.
1, right? I'm going to integrate the density function 1 over this area. You guys see that kind of interpretation of that? So the volume interpretation of this, right, would be that you're figuring out what the area of a cylinder, right, it's got this as a base and is 1 tall. Is that going to be the area of the base? Better be. Otherwise my volume's all dorked up, right?
Are we always going to choose 1 for the density?
Yeah, when you're trying to figure out the volume, you want to choose 1 as the density. If you want to figure out the weight of something with a variable density, then this thing that I'm going to integrate would be the density function. Right? So let's see, I should do a double integral. Should we set this up in both Cartesian and polar? It's fun. Okay, so let's try Cartesian and polar. In polar, what do I need? Should I be integrating the function 1?
It's still
Well,
the density.
Yeah, 1's still my
area.
density.
1 r, so r.
And then I need that d volume, right, or d area, right? Which in the polar case is r d r d theta or d theta dr, whatever, right? Okay, so on both of these, right, this is Cartesian, this is polar, and both of them I'm thinking the integral, right, over the disk or whatever you want to call this thing of 1 the area, right? You see that? 2 different approaches, but the same thing. Which one do you want to do first?
RDR.
Polar?
Yeah, sure.
Okay. So
So if we're doing the R,
so the theta's 0 to 2 pi.
yeah,
What's the radius of my circle?
R.
Probably r, right? I was trying to figure out the radius of an arbitrary circle.
Okay.
Warning. What should I avoid doing here, Donald?
Evaluate.
No.
Working it up.
Working it up. So,
Plugging in r into our limits.
yeah, I have a tendency, right, in my head to say, okay, the radius of the circle is r, right? So if I put this on my picture, then I'm integrating r's from 0 to r, right? And my r's now have 2 meanings, right? One's the dummy variable, the radius in polar coordinates, and the other one is this fixed value of r. That's why I'm picking on Donald. So what should I call it instead of little r?
Bigger.
Or whatever, right? So I'm going from 0 to capital R of r dr d theta. You guys see what you're going to get out of this? This hopefully shouldn't be hard integration, right? Right? So I should get the integral from 0 to 2 pi of
R.
r little r squared over 2 evaluated from 0 to big R and then d theta. So that's going to get me the integral from 0 to 2 pi of big R squared over 2 d theta, which gets you
R squared over 2.
what are you integrating with respect to?
Theta.
Theta, right? So what's this stuff?
That's all constant.
Yeah, it's constant, right?
So we got that theta.
So you get big R squared over 2 times theta evaluated from 0 to 2 pi. So in the end, you get exactly what you ought to get, pi times the radius of the circle squared. Cool? No surprises at all.
Pirates must love integrating circles.
Is this where that definition was like found? With this?
Ish.
Kinda?
So, this worked so slick and easy, right? Because I knew how to measure angles and radians.
Okay.
You guys see that?
Yeah.
If I was measuring angles in something else, this ain't gonna go well, right? So, does the
So we
formula for area of a circle predate radian definitions? Probably not. Is this more or less the heart of it? Yeah, absolutely. Cool. We could figure this out from the definition of pi too, which would be another way to do it. I'll maybe show you that one if we have a chance at the end. How about Cartesian? What would I set up for Cartesian?
The outside would be negative big R to big R.
That's a
Oh, the outside would be.
Outside.
I see. So the y's, right?
yeah.
They're going to range from minus r to r, definitely.
Okay.
Okay, now the hard one is you have to slice this parallel to the what?
The X's.
Yeah, the x's, right? You guys see that? I'm specifying a y, right? So I'm going to slice this way. Why didn't I have to do that with the r's and thetas?
You do it sectors and it just spun around.
Yeah.
Yeah, the radius is always the same, right? It always goes from 0 out to the big R. And the angle goes from 0 once around. Duh, no problems.
X squared plus y squared equals square root of 1 minus.
Good, I want that.
Square root of
So
R minus.
let's see. So I know that this thing's given by x squared plus y squared is r squared, right?
Where do you start?
And so I wanted to solve this for
Y.
For X's.
For R, right? Y. Right? R.
I want to solve this for
Bigger.
x's.
X's.
Right, I'm trying to integrate the x's
Y,
out.
R.
You guys see that? I'm trying to get rid of the x's. I'm asking where do the x's start and end. It's got to be in terms of the other variable, so I need to solve for x. So here, this side of the circle is minus the square root of r squared minus x. How about pi squared? And the other side of the circle is positive math. Square root of r squared minus y squared, right? So on your Cartesian integral, you need to go from minus the square root of r squared minus y squared to plus the square root of r squared minus y squared. Anybody want to sit down and do that one?
Nope.
Nope. You guess what you're going to run into?
Wouldn't the
Undefined things.
No. You should be able to do this.
would the
Definition of pi.
would it be 0, right?
Yeah, so where's the pi going to come in? You guys see that? There should be a pi in this thing, right, in the end? Where are you going to get a pi from doing that? It's in there. Remember the thing I told you we weren't going to do in this class? What did I tell you a couple hours ago that we weren't?
Trig.
Oh no.
Trig sub. See the trig sub right
Yeah.
there.
Yeah, I do like
You guys see that? So your next step on this one, right, is going to be the integral from minus r to r of twice the square root of r squared minus y squared. See y. Does that look like a standard trig sub problem to you?
Yep. For minus.
Yeah, better.
So sine sub.
Cool.
Yeah.
So this is a reason you shouldn't have to do trig sub anymore.
Where we would have to use.
Because if you look at that, you can think to yourself, okay, I can rewrite this, right, as an integration of 1 over a shape I know how to deal with, and then I can convert it to polar and do that instead. You guys see that? So, trig sub. Wave bye to trig sub.
Bye bye.
And there's
It may
this
come up occasionally, but if you're doing things right, you should be able to avoid it. Cool?